Hi everyone, this is Anushka and welcome back to my channel in Economist. So in today's video, we are going to cover a very important topic in your advanced econometrics playlist, which is nothing but panel data, right? So many of you have requested me to make video on panel data. So I have come up with this video, which is going to be an introductory session in your panel data analysis series. I'll be making a series of videos on panel data where we will understand the estimation process in details in the next successive videos. So in today's video, what we will do, we will understand the concept of panel data with the help of some examples, and then we will go into the different types of panel data which are possible. Basically, we will cover what is balanced panel and what is unbalanced panel and which one is better. So we'll do a comparative analysis of the types of panel data, right? So this is the agenda. Now let's start with the concept of panel data first. So what is a panel data? Panel data is also known as longitudinal data. So this is an alternative name of panel data. Now it is a data set where multiple entities, what could be the possible entities? It could be individuals, it could be firms, it could be countries. So basically different cross-sectional entities are observed across time. So there are two different dimensions of this kind of panel data. So panel data, in one word, if you want to know, it is basically a combination. It's a combination of cross-sectional data and time series data. So usually it has two dimensions. What are the two dimensions? As in the definition we have seen, there would be cross-sectional units. Cross-sectional means different entities will be present. It could be firm, it could be different countries, it could be different individuals, and so on. Also, it will have certain time series aspect to it. Time series, the data, the entities will be observed across time. So there are two different variations that we are observing. First is the cross-sectional dimension and second is the time series dimension, where different entities are observed over multiple periods. It can be yearly, it can be quarterly, it can be, you know, different kind of units. It can be daily, weekly, quarterly, monthly, anything that you want, you can consider that. So basically, time series time series, this we have observed. We have made a separate video on time series analysis as a playlist, right? So if you haven't watched that video, so please check that out. I'll give the link in the description if you don't know what is time series analysis. So if you know, there I have explained that in general what is time series. In time series, you consider particular variable. Suppose uh, you consider a particular worker and you basically analyze what this particular worker is producing in the month of, say, January, suppose in the month of February, in the month of March, in the month of April, and so on and so forth. So keeping the entity constant, you basically are measuring what will be the production which is happening by this particular worker in different months. If this is the scenario, then you will call this data as the time series data, that you are taking into account the production in different months. So this is basically the time variation. You are basically looking at the time variation. But the cross-sectional data is a little different, where what you do, you basically keep the time as fixed. You are not taking into account any kind of time variation. The data will be time invariant basically. Now, suppose you are a factory owner. What would be the example for this? You are a factory owner. Suppose you have 10 workers in your factory, 1, 2, up to say 10 workers in your factory. Then what you do for a particular time, suppose for a particular day, suppose this is Monday. Suppose for a particular day, what will be the production by the first worker? What will be the production by the second worker, third worker, along the way up to the 10th worker? So if you are considering this kind of a data where you are keeping the time fixed, you are not changing the time, but you are measuring the production by different entities, right? See, this we call as entities. Entities could be different forms also. Instead of taking workers, you can take different forms also. Suppose you are managing 10 different forms, then what will be the total production in the month of, say, January, in the first form, in the second form, in the third form, all the way up to 10th form? This will also give you cross-sectional data. Now, if you combine these two kind of data, Firstly, you have time series aspects, and second, you have the cross-sectional aspects. If you combine both of them, you will get something called the panel data, right? Panel data is basically a combination of time series and cross-sectional data. I hope this much is understandable. This is basically theoretical knowledge of it. I'll be going into the example and I'll explain, right? So see here first, why do we use panel data? The next thing that we will understand is why do we at all need to use panel data? First thing, and the main point of importance of panel data is that it helps us to find out individual specific heterogeneity. Now, what is individual? It helps us to control for individual specific heterogeneity. Now, if you have both flexibility, if you have two dimensions, two different dimensions, cross-sectional dimension and the time series dimension, then what you can do for a particular entity, you can find out the variation, right? For a particular entity, suppose for a particular worker, you can specifically find out across different periods what is the production that is being done by that particular worker. So this is known as the individual specific heterogeneity. Individual specific. So for different entities, variations can be found out using the different time periods that you are considering. So if you know this individual specific heterogeneity, you can do control also. You can take that into account. You can control it for your specific study. So this individual specific heterogeneity is basically a unique feature of the panel data, which is not present in case of time series or in case of cross sectional data, which is a unique quality in case of panel data. That is why panel data is very useful. Second thing is that it can capture the dynamics over time. It is very obvious. The dynamics means something which is varying over time. So here we have seen that different entities are varying across multiple periods. So you have sufficient data to find out the dynamics of the entities over time. And the third thing is that it uses more data. That is why it will improve the efficiency. So in case of time series data, as I've told you, the variation will be only across time. In case of cross-sectional data, the variation will be only across the entities and not across the time. So here you don't have the complete data. You don't know how the multiple entities are varying across multiple time periods. So if you individually consider both the dimensions, the data will be obviously lower. But when you combine them, the data will gradually grow. The data will be more. The data points will be more. That is why there will be improvement in the efficiency of the data, which are also major reasons why we use panel data. So these are the three basic reasons: individual specific heterogeneity, unique feature of panel data. Then you can capture the dynamics over time of different entities. Also, since the data points are more in case of panel data than usual cross-sectional and time series data, it will improve the efficiency of your study. Right? I hope this is clear. Now I'll move on to show you an example of what I am talking about. So please understand this example. Here I have taken the example of wage determinants of the worker. So basically wage will be the dependent variable which you can see here. Basically we want to know what will be the wage of the worker and how, let us say we are studying how education affects wage. So this is a table which represents the panel data. See, in the first column, you have the worker's ID. So see here I have written 111. So in the first three, 111, why this is so? Because we are measuring for the first worker, what will be the wage? What will be the wage of the first worker in the year 2018? What will be the wage of the first worker in the year 2019? What will be the wage of the first worker in the year 2020? And in this way, all the way up to 2022. So see, this is the individual specific heterogeneity that I was talking about, right? If you don't understand this, please pause the video and try to think. This is the individual specific variation or heterogeneity. Why this is so? Because see, the worker ID, this is the same worker that we are talking about. Worker number 1. This is the first worker, right? So the first worker, we are measuring the wage of him in the year 2018, 2019, 2020, 2021, and 2022 over. So from 2018 to 2022, we are measuring what will be the variation of this worker's wage across different time periods. right? Now we will do the same thing. Then this table, this is the discontinuity here. There is no space to write the entire table. So I have to leave some space. So we'll do the similar thing for the worker number 2 also. Worker ID, worker number 2, you will do the same thing. So there will be a row where you will measure in 2018 what will be the wage, what will be the year of education, what will be the year of number of years of experience, so on, all the way up to 100 worker. So you have altogether 100 workers in your factory, right? 100 workers in your factory, and for each of the worker, what you will see, you will see what will be the variation of his wage, right? What will be the variation in the wage, because wage is the dependent variable here, across different time periods, so here workers are also changing and years are also changing. So this is the cross sectional variation. You are changing the entities here is the number of workers. So first worker, second worker, third worker, up to 100 workers. So these are the different entities, or the cross-sectional units. These are different cross-sectional units that I told you. Cross-sectional variation. This is the cross-sectional variation, and this is the time variation, basically. This is the time variation, or the time dimension, basically. Right. So you have, for a panel data, it is mandatory for you to have different, cross-sectional variation across different time periods. So this kind of data set will give you a panel data. Now see here, I have some additional columns also. Education is also one explanatory variable here, and year of experience is also one of the explanatory variables here. Now what happens if you want to model this situation? Right? If you want to, based on this particular data set, if you want to model this entire situation, then how will you do that? So this thing will be a little different from other things that we have studied so far. If you have seen my other videos on, econometric methods and other advanced econometrics method, you will not, see this kind of a model structure, which is unique to the panel data, where you see you have two suffix here also, here also, here also, here also. See ij. So basic panel regression model, understand this model. Here, a simple model to estimate wage based on the data set that we have understood just now, right? It is based on this particular data set. So as I have told you, wage is the dependent variable, which you can see here. Wage is the dependent variable, but here you have two different suffix, I and T. I is for the cross-sectional units, right? Cross-sectional unit means the ID, basically the ID, workers ID, 1, 2, 3, 4, up to 100. So here I will vary from 1 to up to 100. So this will be the variation, and T is the time period. T will vary from 2018 to all the way to 2022 from this particular table. See, we started off with 2018 and the final data point is 2022. So this is the time variation. So wage will be determined across different units and across different time periods, right? So that is why here you have two different suffix I, T. Beta naught is just an intercept parameter. Beta 1 is the slope parameter with respect to education. Beta 1 basically gives you the impact of the average effect of education on wage. Again, education has this two suffix. Education will also vary across different, entities, across different workers, across different time periods also. So basically, IT suffix is this. And then also you have experience, which is also IT. All the explanatory variables will have this kind of a suffix, two suffix. Now, the interesting thing here is that, which I hope you have not seen anywhere before, is this. See, up till now, we have not considered more than one error term. But in case of panel data, this kind of panel data, this is a specific kind of a panel data where you have two different kind of error terms, right? Which is something unique, which we have not seen so far. Now, please understand why do we need these two different things. Now, in the usage of panel data, I have told you that panel data helps you to find out individual specific heterogeneity, right? Individual specific heterogeneity that can be obtained using this first error term, which is UI. See here, UI is the unobserved individual specific effect. For example, it could be ability. Suppose some of the workers, so here we have 100 total workers, 1, 2, 3, 4, 1, 2, 3, 4, up to 100, 100 total workers. Suppose some of the workers, suppose this 100th worker has some specific ability. right? So he can produce more basically. Suppose, for example, education is the same, experience is the same, but he can produce more. He has some more talent, innate ability. Some innate ability is there for which can influence the wage, right? Education is the same, experience is the same, which is given in the table, but he has some intrinsic ability, some innate ability for which his wage can get affected. He may be paid more, right? If this is the scenario, so this kind of unobserved individual specific effect can be obtained using this error term. So this error term is introduced in the model so that we can capture this unobserved individual specific effect of each of the individuals. I know it might seem a little hard for or you if you are new to this panel data thing. But if you have any questions anywhere, you can let me know in the comment section and I'll be more than happy to reply you, right? So UI, which is the first error term, captures this individual specific effect, which is usually unobserved. Without getting in touch of the worker, you cannot find out what innate ability he has, right? So suppose it happens, that is why it is random, it is error term, it is not usual, it is captured by the error term because it is possible. So we are making room for this possibility. Now the second error term. Now see one thing, that this UI does not have this T suffix. T suffix is not there here. So that is why it is time invariant across time period. It doesn't matter which year you are in. If some factory worker has some specific ability, some innate ability, that will be present throughout. It does not depend on time. Some intrinsic ability if you have, suppose you have very high emotional intelligence, right? IQ, EQ, everything is very high. You are like a prodigy or something, someone. So if that happens, that doesn't come with the year. Time has nothing to do with it. You are born that way, right? Talent, if you have some innate talent, innate ability, then it will not depend on the year. You will have that inside you across all the years. So that is why you don't need to include the time factor here. Time factor should not be included here. That is why see, it is only UI. It is time invariant in nature. But the second error term which you have here, which is known as idiosyncratic error term, which is important. See, idiosyncratic error term. Now, what is this term? So I have explained this error terms more here. Let me show you this. So the first error term we have already explained. UI is the time invariant unobserved heterogeneity. This we have discussed. Basically, for example, a person's innate ability which does not change over time. This we have discussed. Now see this. Epsilon IT. Epsilon IT is the idiosyncratic error. What is this? This is basically the error which varies with time and across individuals. For example, it is some kind of random shock, right? It is some kind of random. Idiosyncratic error basically means some kind of random shock, or it is some kind of unobserved factors, but it will affect the dependent variable at some specific time or specific units. So it has to do with the time variation also. The dependent variable will get affected, but it will have some time variations as well, right? So it is basically a random shock. Idiosyncratic means it is a random shock or unobserved factor, but it has to do with the time factor also and the entity also. It depends both on entities and on the time periods, time units, unlike this time invariant, unobserved heterogeneity. Right? So these are the two distinctions between two kinds of error term that you will encounter in your basic panel regression model. This is not true for all the panel regression model. We will see different models for different kind of estimation. We will go into estimation from the next day on. So there we will see it is not mandatory that in every panel data model you have these two kind of errors. Here I am giving you the modeling for this particular example data set that I have taken. Here you can capture these two kind of different error terms. And since this is a classic example which we use for teaching you, that is why I thought to include this in the note also, right? So these are the two kinds of error term. Now, if you want to know these two kind of error in our example scenario, that is the wage regression scenario, that is what I have written next. So see, for this wage example scenario, UI remains the same. It is the worker's inherent some ability which does not change over time. But what could be the idiosyncratic error? It could be the random things, like a person may get bonus for a particular year. Right, for a single person, a single worker, suppose the fifth worker, I equals to 5. Suppose the fifth worker gets bonus at the time point, say 2021. So this is a particular scenario. This is a particular scenario which varies both across entities and across time. Can you understand this? Please pause the video if you have any, problems, and think for yourself what I'm saying. What is the distinction? Epsilon IT is certain random things which you cannot predict beforehand. Do you know before the year ending that you will get a bonus or not? It's actually not true. You don't know whether you will get a performance bonus or not. The management will decide for you, and beforehand you don't know if you get a bonus or not. So it is a kind of random shock. It is a kind of random shock, and it will vary across entities and across time periods. So here I have taken a specific example for that. So idiosyncratic error can be a bonus, right? This is just an example. Or suppose you are working overtime. So that will also affect the wages. Third thing could be economic conditions in a particular year, which is also not captured by the explanatory variable, but it can all affect the wages. Fourth is some health issues. Suppose you are suffering from some health issues, that will also affect the earning. So idiosyncratic means everything that will affect the dependent variable, that is the wage rate. Wage rate is the dependent variable here, or the outcome variable here. So we are basically capturing all the random things that might occur in some specific time period for across different entities, which might affect the wage rate, but we are not explicitly writing them in the model itself. So they are not explanatory variable, they are random shocks which should be present in a model. There should be some variable which will present these random shocks in a model. That is being done. This job is being done by this idiosyncratic error. Right? I hope this is clear, and this UI is just individual specific variation which is time invariant. For example, inherent ability. Now see here that these are idiosyncratic because it is specific to a person and a particular time. The example that I have given you, everything, every point that I have discussed so far, it is specific to a person. Because a specific person is working overtime, a specific person is getting the bonus. For a specific year, economic condition is getting better or is getting worse. And for a specific person, you will have health issues. So it is basically specific, either to a specific entity or for a specific time point. And the second thing is that it is unpredictable, random in nature. That is why it is an error. It is essentially an error. So these two types of errors can be present in our model. So in every model, these two things are not present. For some model, only this will be present. For some model, only this will be present. Or in some model, both the error terms will be present. Right? I hope this much is absolutely clear to you. So this is the first part of our lecture where we have discussed what is panel data in details, and we have seen a basic panel data structure also. Now, in the second part, I want to explain what are the different types of panel data which are possible. And here we have two types of panel data. First is the balanced panel, and second one will be the unbalanced panel. Now, what is balanced panel? As you can see here, balanced panel is when all the individuals, that is all the cross-sectional units basically, are observed for the same number of time periods. So see this example will help you to understand this. Suppose you have only three individuals. So three cross-sectional units, I equals to 1, 2, 3. So these three cross-sectional units are there. Now, if you have the same number of time periods also, 1, 2, 3. If the number of cross-sectional units is exactly equals to the number of time points across which you are measuring them. So see here you have three different time points, 1, 2, and 3. And all these data are present. These are all different data points, 1, 2, 3, 1, 2, 3, 1, 2, 3. So all these different data points are present. So you can individually collect all this. Here I have, marked this as a tick mark, right? Green tick mark. But basically it denotes that you have some specific values. You know for a specific individual what is the year one value here. Some specific value, some specific value, some specific value. So all this will be values which are present to you or which are known to you. Right. So, so there is no missing value. In other words, you can say that there is no missing value. There is no missing value in your panel data. If this is the scenario, then you will call this a balanced panel. Balance means in the length and in the breadth, your panel is balanced. That is, there does not exist any kind of missing data. So all the values that you want are present to you, and also the number of cross-sectional units is exactly equals to the number of time periods that you are taking under consideration. So the exact opposite thing will be unbalanced panel. Before going into that, let me show you what will be the different advantages. So balanced panel is the one thing that we always strive for. We always want to make our data set as balanced panel before doing into any kind of estimation. Because why this is so? In case of balanced panel, every individual has complete data for all the time points. There is no missing data. We always strive for this kind of a panel because there is no missing data. And if you do not have any missing data, it becomes very simple to handle. This is the first advantage. Then you have estimators are easier to compute. We will do this in the next video. We'll go into estimation in the next video in details, and then we will discuss this more there. And the third thing is that less chance of bias from the missing data. Since you do not have any missing data, it is less likely that you will have bias in your analysis. Right. So it is always better, it is always advisable to use balanced panel. Even if you have unbalanced panel, first try to convert it into balanced panel and then go into estimation. So this is about the balanced panel, and then let us move to the unbalanced panel. Unbalanced panel, as you can see, when some individuals are not observed in all time periods and there are some missing points. So in this example, if you see here for the Cth individual, this individual C, for the first year, this data is not present. You don't know what is this value. And for the second individual, for the second year, you don't know what is this particular value. You don't know these two values. So you have missing data available. Missing data. So number of cross-sectional units are there, but some values are missing. You actually cannot know, you actually do not know what will be the values for these two time points. So what you can do, you will basically do imputations. You will, apply different kind of approximation methods to find out, to put an estimated value of what it might be, to put an approximate value of what these values might be, but you actually don't know what are these values. This will give rise to unbalanced panel. That is, for every cross-sectional units, for every time point, you don't know what is the actual value. So see, here is the panel when some individuals are not observed in all the time points. There exists some of the missing data points. Right, so this is unbalanced panel. Unbalanced panel can also happen if you suppose that you have 3 individuals, but you have only 2 year of data. Suppose this third year data is not available to you, then also it will become unbalanced, because see, you have 3 cross-sectional units but only two time points. So this will also be kind of unbalanced panel. Also, it can be the other way around, that suppose this C individual is not present. The individual is not present, you have 2 individuals and you are taking into account the data for 3 time points. Suppose only this much is there available to you. This will also give rise to unbalanced panel. So whenever the length and the breadth, so number of rows and the number of columns, basically they are not equal to each other, or you have some presence of missing value in your data, this will be unbalanced panel. Right? So they are different. Unbalanced panel. Balanced panel will be only when you have the number of cross-sectional units and the number of time points, time units that you are taking into account. They are equal in number and all the data points are individually present. There is no missing value. Then only you will have balanced panel. Now the final thing that I want to share with you is that suppose you have this unbalanced panel, then what will be the problems? So individuals will have incomplete data, missing values are present. That is why individuals will have incomplete time series data. Now, why will this unbalanced panel may appear? What are the reasons for unbalanced panel? It can be due to survey dropout. Survey is not conducted properly. Late entry into the sample. The entry is not made accordingly in time. Or there will be missing or corrupted data. Lack of data, basically. Lack of knowledge, lack of information. That is why missing value is found. Now, if this happens, what will be the challenges? The challenges are just, just the opposite thing, what we have seen in case of balanced data. Challenges will be more complex estimation. If you have unbalanced panel, it is not advisable to go for the estimation process. Before that, we have to try to make it a balanced panel, then only we can go for estimation. It is advisable, because if you have unbalanced panel and you are applying estimation methods, that will give rise to different kind of biases. So more complex, the estimation process will be more complex. That is why we should avoid it. Second is may require data cleaning and imputations. If you have imputation means you will substitute the missing value somehow. There are different approaches for imputations. You will use some of the method and you will try to approximately put some values, try to impute some values. You will try to substitute the missing values. And third is that still usable in the modern econometrics, especially with the large sample, but the process will be more complex, right? So it is advisable that we must work with the balanced panel. And this is the final thing that we will see. And then we will stop for today. That what are the, this is a kind of comparative study. You can take a look at this. That balanced and unbalanced panel, we know in case of balanced panel, same periods for all. For all the entities, cross-sectional entities, you have the same number of time points. All the data are present. There is no missing value. In case of unbalanced panel, different variations are possible. For lesser, it can be that the number of cross-sectional units are lesser than the number of time points. It can be the other way around also. These two are possible. Also, there could be presence of missing values, which we have seen in our example. That will also give rise to unbalanced panel. Now, if you have the balanced panel, pros will be it is easier to model and to analyze. But in case of unbalanced panel, it is more realistic and more flexible. So in real life data, we often see that missing value is present. So unbalanced panel is a very realistic scenario. It is more flexible, but it needs further modification before estimation. And cons will be what? If you have balanced panel, it may require dropping out missing units. But in case of unbalanced panel, it is harder to model and interpret, right? So if you have unbalanced panel, you have to convert it into balanced panel first, and then you can go into estimation. That we will see in the next video. So there are different kind of estimation methods that we can do using the panel data that we will start from the very next day, right? So thank you so much for your time for listening to me. I hope panel data is clear to you. If you have any questions anywhere, please let me know in the comment below. And I'll meet you in the next video where we'll go into estimation process. And as of now, if you like this video, give me a thumbs up. Do subscribe to this channel, AN Economist. That gives me immense motivation to continue making such useful videos for you every single week. So please show your love and support towards my endeavor, and let's meet you in the next video. Thank you so much for your time.